3 case studies, from our network. Of course, we have way more case studies than 3. Happy to share them with you, later on, maybe in a more detailed manner. If you have any questions, we can hopefully answer. Now, what you need to know is that we provide the software, we train on the software. We have today, self-guided training, free of charge, of course, with our partners out there. But we don't know really how our software is being applied sometimes. But for these case studies, we did we contacted our customers and we know how to do. So just for you to know that we do not do normally consultancy services unless rarely. Okay. So our first case study I wanted to highlight is with Bristol Water. Okay. So Bristol Water, they had 2 things really. First, they wanted to look at the critical links, right? And the other thing, they wanted to look at the water, the water quality. So a bit of background about Bristol Water. It supplies over 1 million people within Bristol, England. The operations include, storage, treatment, distribution of water, uh, but they only focus on water, right? They're not focused on wastewater and stormwater, etc. So they're a water utility, and they cover about a huge network, in the UK. The project objective is to understand where to prioritize these investment, right? So they need to understand where they can prioritize investment and how they can minimize any impact of the customer, of course, while they add more elements or more network as well. And the challenges were, 3 challenges are listed here. So they have almost 7,000 pipes in their network. So it's a network that we normally do more than, but it's for sure one of the networks that was interesting in terms of the data that we found in there. So they would like to know, as I said, which pipes are critical and supply the most to the customer. And the other goal was to ensure water systems, the water supply systems are okay when it comes to water quality, right? So they had some water quality problems that they wanted to look at. And the last thing is they wanted to, of course, reduce that customer contact, reduce the complaints by 10%. So these are the goals that they set up initially. So first, I'm going to give the result, or the solution really here was regarding the critical pipes. So they use InfoWorks WS Pro for critical link assessment to do analysis on the main mains. On this picture, actually, in fact, on my right-hand side is from Bristol Water. And they wanted to understand also what pipes were affected, which is what they got to for around 25,000 people. Some of it they needed to redesign, but anyway, they got to that point using InfoWorks WS Pro. The other thing I wanted to mention is when it comes to water quality, right? So they wanted to know what they had some problems, some contaminants in their network, and they wanted to do what we call reverse trace analysis, right? So they wanted to trace back the constituents where these problems came from. So they conducted that reverse analysis. Of course, they based it, number one, on customer complaints. They based it on some data that they have, and they used basically SQL queries. We have some SQL queries, which is something I didn't input. There are many things you can do with them. You can even skeletonize and automate some certain aspects in your model, and even sometimes if you're missing certain information, it will fill in the voids between certain things. Certain pipe, for example, is missing, or profile is missing. It gives you a place to start to simulate your network. So back to this case study. So they develop some SQL queries and create some spatial representation of these customer complaints. They wanted to map them and they want to understand where they are. So, and then they ended up tracking back basically these complaints, and tracking back these water quality problems. So the outcome was to determine which forest mains to renovate. So they needed to renovate certain, which might be actually one of the questions about the age of these, these. I think one of the gentlemen asked a question about the age of these, of these pipes. So uh, we don't do it, as I said, indirectly. It could be like reverse, do it in a reverse manner, but it wouldn't be like a place where we can do it indirect. So indirectly, so you do it like reverse, whether it's water quality, whether it's roughness, you can do it indirectly. But I would like to look at this particular question more, maybe to give you a proper answer. The second outcome was, of course, they partnered with Bristol University, and they developed some sort of like cleaning approach, right? So this is outside InfoWorks WS Pro. We have, as I said, we have some flushing simulation, and you can do some flushing tools, but of course they developed themselves some cleaning approach with Bristol University. And some of the achievement was, as I said, initially it was 10%. They wanted to reduce the customer complaints. They ended up reducing them by 20%, and basically they ended up pinpointing the water quality problems stemmed from the old forest mains, and they renovated them. And yeah, that's mainly the two achievements that they had. You can also read one of the quotes that we had from John Scott, who is the water quality scientist inside Bristol Water. So that's that's the first case study I wanted to highlight. Of course, I will send you later on maybe a full-fledged case study about the details and everything else that it comes, as far as the hydraulics, as far as the certain results that they got. And the other case study here is with SA Water, that's South Australian Water. And South Australian Water did not only use InfoWorks WS Pro, but they use also IW Live Pro. Now, so a bit about South Australian Water. So it's a utility that provides both water and wastewater to around 1.7 million customers. So it's a huge utility. They manage the metropolitan network, which is about 500,000 connections for 1.2 million customers. They have some treatment plants. They have some huge demands also in the plants. And their goal was to basically understand, basically climate-driven demand. They understand, they want to know what forecast or what demand affects certain network. They wanted to know also if in case where there is a problem in the network, or there is a problem in certain treatment plant, what would be the solution really when that situation happens. So they run several scenarios with InfoWorks WS Pro, and they run counter scenarios or solutions to every single scenario. So that's what they did with InfoWorks WS Pro. Now, as how big the model is, it was a huge model. I mean, we have models with over 1 million links, but here, you have 100,000 links, 110,000 links, 120 tanks, 150 pump stations, and 70 customer categories. These customer categories is based on, of course, their preference and how they categorize them, but you can also input them in the software. And again, so that's what they use to have the scenarios. But on top of this, they wanted IW Live Pro, so they can see if there is any change happening in the network, so that 24 hours, 48 hours before that problem starts to grow and becomes a real issue, then they can get the warning, and they can pick one of the scenarios that they have already input. They've already done the consultancy work for it, and they can use it and tackle that problem before it actually happened. Whenever it's like sending the crews or even warning the people, whatever they needed to do, they did it. So as a result, they really designed this this kind of network, and from a design from also an operational side according to their needs. They ended up even lowering the operational risks, and they actually ended up reducing the electricity consumption. So they start to have even more understanding of the network on when to turn on the pumps, to turn off the pumps, when to close the valve, what is the best way or best way to take an action. So really, that's what they did in South Australian Water, and of course they improved the accuracy of the live model. So they have as I said, you can always start from the offline model with no further information, start to calibrate your model. And once you have your SCADA, once you have, this data, you can connect them to InfoWorks WS Pro. You can have that feed to IW Live Pro, and then you can start doing some automation as well. So the more big data you have, the bigger big data you have, the better, of course, you will get into that digital twin, get into that journey of digital twin. But to start with, you can start with whatever you have today. Okay. Here I'm not going to get too much into detail, but basically, just to show you how big is the live model is, just the live model, they had about 800 live data feeds, that's coming from SCADA, from whatever result that is in there, and they have three main inputs. One of the basically models that they actually looked at inside South Australian water. All right, so that's the second example. The third example here is with Anglian water. Now, Anglian water is gigantic. I said Bristol water is big, Anglian water is even bigger. And I know we have examples here with the UK, but we're having some case studies hopefully in the Middle East, some case studies in South Africa coming out hopefully by the end of the year or next year. These for us to make a case study and share it, we need to get a lot of approvals from them for us to publish them. Now for Anglian water, as I said, this is, there's a bit of some on my right-hand side here. You can see how many assets they have and how big is the network. But just generally, Anglian Water it supplies water to 4.3 million people and collect wastewater from 6 million people, as well as there is the stormwater supply involved. The network is huge. It's about 40,000 kilometer water mains and about 80,000 kilometer of sewers or wastewater. Operates about 143 water treatment plants and about 1,200 sewer treatment plants. The problem with them was, they had some outdated models which actually impact some serviceability and efficiency. And the objective for them was to improve that accuracy of the model representation, and also minimize any service interruptions. This, like if you manage any network, you'll see there will be some service interruptions out there. No matter what country you look for, whether it's the UK, the US, or Nigeria, you have these issues where you can have some service interruptions issues. And for you to get over these, you need to have a very good understanding of your network. Again, they use InfoWorks WS Pro and they use IW Live Pro. They use InfoWorks WS Pro for the offline model. And once they have this offline model, once they have everything calibrated, then they start using the automation. They start to read what's happening in the past and get that warning system of what's happening in the future, and leverage that big data, which is, I keep repeating that, but it is something that we really excel at. Okay. Besides how fast your simulation is, you wouldn't be able to run a simulation every 2 hours or every 3 hours if the brain of InfoWorks WS Pro of the engine is weak. But the engine is very quick, it's very accurate. It will be able to do these simulations for you. Of course, that will depend. Maybe you have a bigger network, maybe it will take 4 hours for it to run, but you always have the simulation engines. You always have the remote sims that you can do using high performance computers, beside the cloud that we mentioned earlier. So for the results, they had the ability, I guess, to integrate with their models, with their GIS, with their SCADA, with their SAP network inside Anglian Water, and they have the ability to continuously really rebuild and calibrate their model and using real-time data. So that's the advantage that you get from IW Live. You have the ability to, in near real time, you are calibrating your model and you are changing your boundary conditions, and then you're basing, you're getting new data, you're getting new models based off of that. Of course, they ended up improving their services, and they reduced their complaints, and they started having this proactive management, whereby you don't wait for a problem to happen. Problems will happen in the network, but at least if you know that there is a problem that is brewing, or an issue that is brewing in the network, then you can start to adjust it and tackle it before it's becoming a huge issue, whether it's leakage, water quality, transient, fire flow, anything. Okay, and that's that's very similar to what I what I showed earlier with with InfoWorks WS Pro and IW Live. So basically that you have the ability to you have that once you have these two systems when you build your offline model, then you have your hydraulic simulation. You have the basically the base InfoWorks WS Pro. Now IW Live will connect with network optimization. Will connect with the network and will start to try to optimize the network. Give you some warnings. It will give you some telemetry, connect with the telemetry updates, and you'll see the forecast as well. So once you connect with all of this, it will again make a loop and will take this new found data or the new data, and then you can get the new report, and that way you'll be able to understand how you manage the warnings better, understand how you can tackle this particular issue better, etc. So that's basically really generally speaking what we can do with InfoWorks WS Pro and IWL Pro. Hopefully, it's still some time. Try to be a bit quick, but yeah, basically these are the case studies I wanted to highlight today.